Why I'm skeptical of rewriting JavaScript tools in faster languages. Oh boy. Everyone's favorite topic. JS is obviously way too slow. Why are we using it for all these things? Why is Electron the thing that we're writing our desktop apps in? Why are our backends in JavaScript? Rust is right there. Have we all been led astray? Or maybe is there some merit to these JS apps being written in this way? And are those performance benefits real? And how big are they? And is the velocity we lose worth it? Or are we just all being dumb and lazy and using JavaScript because it's what we know? These are all great questions, and I'm sure both this article and my answers are going to be quite controversial, so make sure you stick around for that. But real quick, before we dive in, a word from today's sponsor. I've done a lot of hiring through my career, and it's never been easy, but nowadays it's insanely hard, like way more than it's ever been, primarily because we're getting spammed with terrible AI-generated resumes and all this other crap that makes filtering through and finding good candidates nearly impossible. Thankfully, today's sponsor, G2I, is here to help. These guys make hiring great engineers almost weirdly easy. These guys have over 8,000 incredible engineers on tap, ready to go at any given time. And not like people who just got out of boot camp. These are engineers with many years of experience at Fang and other similarly leveled companies. They know what they're doing. Oh, and they're not like 5 years out of date. Most of them already know how to use all the fancy new AI tools like Cursor, so they're not going to slow your team down or move slower than you'd expect. They know how to ship. You want to be sure those engineers are a great fit, which you really should be if you're hiring them. You can write up a handful of questions. They'll find the right engineers to be a fit for that archetype. And then they'll ask those questions and send you through their video platform a set of interviews they do quickly so you can watch them and see who's a good vibe. Once you've filtered down to the people you like, you can do actual interviews with them and very quickly get awesome people in your pipeline. They love bragging about how quickly they get people to ship their first PR. They claim 7 days from interview to PR. I thought this was bullshit until I scrolled a bit further and talked to some other people who have used them. ShopMonkey was able to hire 17 great engineers in 60 days. Do you know how many recruiters you would need to do this and how bad some of those engineers would have been and how annoyed your engineering team would have been doing all those interviews? I don't even want to think about it. When I was doing interviews at Twitch, a loop would be a full day for the candidate and every engineer on the team would have to interview them. That's 2 hours lost per person, then another hour lost later on when we do the meeting to decide if we're hiring them. What if that all just went away? You had a shared Slack channel, you could ask questions and just get handed incredible engineers ready to go in person at big cities or remote if you're anywhere else in the world. It's incredible. I've been amazed at how many of y'all already started using G2I and been blown away. For everyone else, give them a shot today at soydev.link/G2I. Let's dive in. I've written a lot of JavaScript. I like JavaScript. And more importantly, I've built up a set of skills in understanding, optimizing, and debugging JavaScript that I'm reluctant to give up on. This is a good, honest opening. Most articles I've seen like this have not been as honest about the writer's experience and where their biases are. Obviously, if you write JavaScript for a living and you know the language really well, you're going to be more reluctant. I personally am not very good at JavaScript. Okay, joking, I'm a JS engineer. I'm known for that at this point. Obviously, I lean TypeScript, but same difference. I know the language pretty well at this point. I still dearly miss Elixir, but if something can be done in JavaScript, I probably will do it in JavaScript. So maybe it's natural that I get a worried pit in my stomach over the current mania to rewrite every node tool in a faster language, like Rust, Zig, or Go, etc. Don't get me wrong, these languages are cool. I've got a copy of the Rust book on my desk right now, and I've even contributed a bit to the Servo for fun. Servo's the Rust-based JS runtime for Firefox and Mozilla. Oh, sorry, I was wrong about Servo. By the way, Servo is the web rendering engine. It's not the JS runtime. My bad, I'm dumb. But ultimately, I've invested a ton of my career in learning the ins and outs of JS, and it's by far the language I'm most comfortable with. So I acknowledge my bias and perhaps overinvestment in one skill set. The more I think about it, the more I feel that my skepticism is also justified by some real objective concerns, which I'd like to cover in this post. I have so many tangents I want to go down. I'm going to resist that urge as hard as it is. We will get there. So if you want to see how I make this about React Native, stick around, I have a way. Performance. One reason for my skepticism is that I just don't think we've exhausted all the possibilities of making JavaScript tools faster. Marvin Hedgemeister has done an excellent job of demonstrating this by showing how much low-hanging fruit there is on things like ESLint and Tailwind. What is this that we have here? Yeah, Marvin's a legend, by the way. One of the most legit JS devs ever. Yeah. Creator of Preact, if you wanted a good qualification there. A lot of the work that he did here to prove that we can make the JS ecosystem better was doing things like avoiding unnecessary type conversions or creating functions inside of functions if you don't have to. And he did this in a bunch of libraries to make them significantly faster. He would look at the flame graphs in the charts, be like, oh, there's things here that we can do to speed this up. So in this parsing example here, for valid Tailwind class names, it took 400 milliseconds previously, and you got it down to 92 milliseconds pretty quickly. And there's a lot of hacks you can do in order to make Tailwind faster by not having its parser do as much inline shit. Makes sense. So clearly, you can make your JS code faster, even for popular things. But they're also rewriting half these things in Rust right now. Is that worth it? In the browser world, JS has proven itself to be fast enough for most workloads. Sure, WASM exists, but I think it's fair to say that it's mostly used for niche CPU-intensive tasks rather than for building a whole website. Yeah, that is very fair to say. So why are JS-based CLI tools rushing to throw JS away? The big rewrite. I think the perf gap comes from a few different things. First, there's the aforementioned low-hanging fruit. For a long time, the JS tooling ecosystem has been focused on building something that works, not something that's fast. Now we've reached a saturation point where the API surface is mostly settled, and everyone just wants the same thing, but faster. Hence the explosion of new tools that are nearly drop-in replacements for existing ones. Roll down for rollup, OXLint for ESLint, Biome for Prettier, TurboPack for Webpack, etc. However, these tools aren't necessarily faster because they're using a faster language. They could just be fast because, 1, they're being written with performance in mind, and 2, the API surface is already settled, so the authors don't have to spend development time tinkering with overall design. Heck, you don't even need to write tests. Just use the existing test suite from the previous tool. All really fair points. You know the expression, make it work, make it right, make it fast? Imagine if all three of those were rewrites. Make it work was the first attempt to write it. Make it right is you fixing all the things that are broken. Make it fast is you realizing this was all a mistake, so you throw it away and reset. The language you do the rewrite in doesn't matter that much. Obviously, Rust is faster than JS. We're not saying otherwise. But fast.js is faster than slow.js. And I think a lot of the problems that we run into are that JavaScript can be written in terrible ways. And when we're patching hack upon hack upon hack, upon plugins, upon frameworks, upon build tools, upon bundlers, where we're living in worlds with dozens of these Webpack plugins stacked on each other in terrifying ways, a new language is not going to magically solve the problem. A rewrite is, and if the rewrite happens to be in a new language, it will be much better, but it could have just been in JS. It's a fair thing to consider. In my career, I've often seen a rewrite from A to B result in a speed boost, followed by the triumphant claim that B is faster than A. However, as Ryan Carniato points out, a rewrite is often faster just because it's a rewrite. You know more the second time around, so you're paying more attention to performance. Oh, this is a stream snipe. Damn. Massive respect, Nolan, for being deep enough in the trenches to pull out a snippet from a Ryan Carniato stream. Let's listen to this snippet quick. You have my curiosity.
Be careful too. I actually have to warn people about this when they choose Solid, which is like the fallacy of the rewrite, so to speak. Like every time you rewrite something, generally you get better results. So like when people show me like, oh, check this out, we rewrote this is Solid and show all these better metrics, and I'm like, I'm glad. That makes me happy to see it doing what it intended to do. But I'm also say like, it would be really interesting to see how good it would have been if you rewrote it in React. Because my suspicion is like, there are cases, especially performance sensitive ones, where it can make a difference. But a lot of times our biggest wins are from when we realize how to do things better because we're writing it the next time or the second time.
Perfectly put. Thank you as always, Ryan. By the way, if you're not subbed to Ryan's YouTube channel, see the bell? I have that on for like 3 channels. His streams are every Friday. They're awesome. They're where I get my information. Phenomenal streams. Definitely go check them out. Even the VODs after the fact are worth watching. If we're talking about Solid and Ryan, we're only a stone's throw away from bytecode and JIT, so I'm not surprised this is where we're diving in. The second class of performance gaps comes from things that browsers give us for free that we rarely talk about. The bytecode cache, as well as the just-in-time compiler. When you load a website for the second or third time, the JS is cached correctly. The browser doesn't need to parse and compile the source code into bytecode anymore. It just loads the bytecode directly off disk. This is the bytecode cache in action. If you're a bit confused about what that means, JS is an interpreted language. It is running in an engine at a runtime. But the actual JS code that you wrote isn't the code that is being run. That code has to be transformed by what's called the JIT, the just-in-time compiler, that turns that into actual bytecode that can run on your device. Turning the JavaScript into bytecode is a process that takes time. It takes enough time that Vercel went out of their way to cache the bytecode on lambdas and on serverless functions and saw a meaningful performance improvement. Since Vercel runs JavaScript on the server, and it's spinning up a new server, so to speak, whenever a user makes a request, because it's serverless, if it has to download that JS code, convert it into bytecode, and then respond to the user's request, that's a lot of wasted time. And when they moved over to bytecode caching, when they shipped their Rust core, they were able to reduce cold starts by up to 27% because they didn't have to do that transformation step. Chat's making some good corrections. Technically speaking, the thing that converts to bytecode and the JIT compiler are different things. And the JIT's making the bytecode more efficient, but it's layers of transformations where the JS code becomes something more and more specific to your machine that is work to do to generate, but it runs much faster once it's done it. So your browser is smart enough to cache the resulting bytecode from these transformations, as long as the hash and the cache entity for the JS file you're loading hasn't changed, which is really nice and cool. Oh, the article even calls that out. So going from JavaScript to the bytecode always happens. But if a function is being called often enough, it will get optimized even more by the JIT to be perfectly optimized, not perfectly optimized, but much better optimized machine code. And if you can cache all these things, the cost of doing this generation matters a lot less. In the world of node scripts, we don't get the benefits of the bytecode cache at all, unless you're on Vercel. Anyways, every time you run a node script, the entire script has to be parsed and compiled from scratch. This is a big reason for the reported performance wins between JS and non-JS tooling. Thanks to the inimitable Joey Chung, not familiar. Okay, I already like her. Just from the profile picture and the addition of compile caching to Node, I already like her. Easy follow. Easy follow. A committer to V8. V8 is terrifying to commit to. Good shit. And apparently PHP has had an equivalent of this for a while now, which is funny. Part of why PHP finally got fast with 5.5. Makes sense. Hilarious. Anyways, we have here export node compile cache /.cache node.js compile cache. I've set this in my bash RC on all my dev machines. I hope it makes it into the default node setting someday. You know what? I'll do it. Fuck it. I'll report back if it breaks. You've won my attention. Pretty cool that this will now, by default with node, cache the bytecode that's being created. The big thing this will help with is spinning up a script when you run a command. So when you run the Tailwind generate command or you run pnpm run dev, those types of things, more and more of that could be cached, which is really, really cool. As for JIT, this is another thing that sadly most node scripts can't really benefit from. You have to run a function before it becomes hot. So on the server side, it's more likely to kick in from long-running servers than from a one-off script. And the just-in-time compilation can make a big difference. In Pinaforce, I considered replacing the JS-based blur hash library with a Rust version before realizing that the performance difference was erased by the time we get to the 5th iteration. That's the power of JIT. That's kind of nuts that the blur hash JS version gets just as fast as the Rust WASM version after you've run the JS version enough times for it to get jitted. He's shouting out all of the legends in the community right now. Canada Honk is a fucking legend. I already did a video about Porphyr. It's a JS runtime in WASM. It is as complex and interesting as it sounds. Go check it out if you haven't. You know that Oliver is legit because they not only have created a JS runtime at 19 years old and also been invited to Winter CG, they also created Test 262, which is a tool to see which JS engines support which things. What's up with the site? Normally, there's a lot of other engines on here. Must have had a bad run. Bad timing. It's a complex site, so I get it. Yeah, normally it looks like this, where all the different JS engines have their compatibility measured across the official spec of JavaScript, which is super, super helpful for figuring out what engines are capable of what stuff. And obviously, Canada Honk is somebody you would want to trust when it comes to everything JS engine-wise. So it makes sense that they're getting cited here. Anyways. Maybe eventually a tool like Porphyr would be able to do an ahead-of-time compilation of node scripts. But in the meantime, JIT is still a case where native languages have an edge on JS. I should also acknowledge that there's a performance hit using WASM versus pure native tools. So this could be another reason that native tools are taking the CLI world by storm, but not necessarily the browser front end. Fair. It's like when you're using WASM, even just the cost of going into and out of the WASM layer is high enough that you often lose the performance benefits. And if you're doing that back and forth often enough, you're just kind of fucked. Contributions and debuggability. This is the thing I was going to harp on, and I will do a long tangent about it once we get to the right point for it. Let's read first, though. I hinted at it earlier, but this is the main source of my skepticism towards the rewrite it all in native movement. JS is, in my opinion, a working class language. That's such a banger. As they were saying, JS is a working class language. It's very forgiving of types, which is a reason that they're not a huge TypeScript fan. Oh, I mean, I get it. I understand. But, the only L thus far. It is also very fair to say JS is easier to pick up than Rust. Anybody saying otherwise doesn't understand either language. But also, since it's supported by browsers, there's a huge pool of people who are already conversant with it. Not gonna pretend I know what that means, but the way I frame this is JS is a necessary evil because if you're writing applications that run in the browser, you need JS for those. If you don't have any JS in your browser apps, you are limiting what you can do with your functionality, with your software. And JS is effectively a necessary language if you're building applications in the browser. You can hack around it with Rust, but even then, when you're using WASM, you have to have JS bindings somewhere. You can use JS somebody else wrote and use something like HTMX to throw in new HTML changes from the server. But the more dynamic and the more powerful you want your browser apps to be, the more necessary JS becomes. So if we've accepted that JS is often necessary, we need to use it now. We now understand JS is a necessary language. If we can make it work well on the back end, why should we have to use other languages too? If we treat JS like what it is, which is a necessary default, now we need really good reasons to leave that default. For years, we've had both library authors and library consumers in the JS ecosystem, largely using JS. I think we take for granted what this enables. For one, the path to contribution is much smoother. To quote Matteo Collina, Matteo is one of the biggest Node contributors, by the way. Also, Fastify, Express, they're deep. Most devs ignore the fact that they have the skills to debug and fix and modify their dependencies. They are not maintained by unknown demigods, but by fellow devs. I will say, having been in a lot of ecosystems, JS is the most willing to let you change how things work and dive in on a PR. There are plenty of devs who aren't even JS devs now that got their start by doing contributions to JS repos in the public. It's such a welcoming and open, I don't want to say like the whole community is super welcoming because that's never the case anywhere, but it's just so big. And we are all so used to contributions. And so much of our core ecosystem comes from these open community things that I found it to be more open than a lot of other places. And there's also pieces that make this easier. One fun version, and I'm curious how many of y'all know about this, Patch Package. Patch Package lets app authors instantly make and keep fixes to NPM dependencies. It's a vital band-aid for those of us living on the bleeding edge. As someone who was very bleeding edge for a long time, I spent a lot of time with Patch Package. It lets you go into your Node modules, edit a package because it's not doing what you expect it to, and then you can run this Patch Package command to generate a diff that will now be in that repo, and when somebody runs an npm install, it'll apply that change to the package. So you can effectively maintain a fork of an existing package as a little diff inside of your repo. It's super convenient. I have relied on this far too often for far too many things. Thankfully, I'm not shipping it in a whole lot of stuff, but others are. I don't think there's any other language that has this type of culture around users patching the dependencies they're using to do exactly what they want them to do. It's up to 2.6 million installs now a week. That's crazy. Hopefully you don't need this package, but the fact that it exists and gets that many installs says a lot. One of my favorite things this package does is the create issue flag. This will automatically open a GitHub issue for the repo for the package with your diff to let you quickly start the conversation with the creators to say, hey, I have this patch package in my project because I was having issues with the package. Here is the diff for what I changed. Can we talk about this? Yeah, there aren't other communities that are that embracing of letting you do things however you want. And this comes at a cost too. It means like the floor, like the worst apps you can make in JS are horrifying. These people will do a ton of these things. But if you're doing things the right way, you can make changes and unblock yourself at an aggressive pace, which is really cool. This breaks down if JS library authors are using languages that are different and more difficult than JS. They might as well be demigods. Let me show an example of this. Here are two popular repos on GitHub. We have Webpack and we have ESBuild. Surprisingly close in star count. Webpack's at 65k stars and ESBuild's at almost 40k. They're nowhere near comparable in popularity, but they're pretty comparable in reach. I want to show something interesting in these repos. We're going to go to Insights and look at the contributors chart of all time. And what we'll see here, sure, Sakura's the main contributor, and sure, they've fallen off as they've went to focus on all things TurboPack. There's 8 people who have made over 100 commits to Webpack. It is accessible. It is a terrifying repo, and I would not recommend many people go through here to make changes unless you have really good reasons to. And even then, you don't need my advice on whether or not you should do it. You'll know if you should. Let's quickly compare that to ESBuild. Insights, contributors. That's a little bit different. Evan has made almost 4,000 commits. The next highest committer has made 16. There are only 2 people who have done a 2-digit number of commits to ESBuild. Everyone else, it's quite a bit smaller. Usually it's 1 or 2 commits with very small changes. Why is that? Why is this not getting more contributions? Is Evan evil and refusing to accept PRs? Not quite. ESBuild is a lightning-fast JS builder written in Go. Not a whole lot of JS devs know Go, so not a whole lot of JS devs are contributing here. In fact, ESBuild is so hard to build around and build things like plugins for that most people don't use ESBuild directly. They use Vite, which wraps ESBuild for dev mode, and it wraps rollup for prod mode. You can see that here because there is no Go in their contributions. And if we were to hop over where we just were before to see who's contributing, you'll see one of the healthiest contribution charts you've ever seen. There are a lot of people contributing a lot of stuff here. And Patak's a fucking god for taking over as hard as he has, and Safi's been stepping up too. There's a reason that the JS world contributes to things that are in JS and not to things that aren't. And it's not because the maintainers are evil, and it's not because of skill issues. It's because we know JS, and it's a lot less scary to throw JS code at a JS project that is being used in our JS project. Oh, are we about to get to all the things I just said? That's hilarious if so. For another thing, it's straightforward to modify JS dependencies locally. I'll often tweak something in my local node modules folder when I'm trying to track down a bug or work on a feature in a library I depend on. Whereas if it's written in a native language, I need to check out the source code and compile it myself, which is a big barrier to entry. Really important point there too. If you're using Rust code from a package instead, I now have to recompile it if I want to test the different outputs. Obnoxious. Somebody did drop a good counterpoint here with the OXC project having a lot of contributors, because OXC is a set of tools for doing JS linting, parsing, etc., written in Rust. And they have a much wider set of contributors than everything I showed other than Webpack, which is cool. But if I recall, they are contributing to different parts. I can only get so much info quickly scrolling through this, but my guess, and I could be entirely wrong on this, is that most of these people have a specific thing within OXC that they're focused on, because there's a bunch of different packages. There's a bunch of different packages. This is like 20 projects in a trench coat. Regardless, it's a good point that there are a lot of people contributing there. Thank you for bringing that one up. Author calls out TypeScript here, and I think this is fair. As they say, to be fair, it's already gotten a bit tricky thanks to the widespread use of TypeScript. But TypeScript's not too far from the source JS, so you'd be amazed how far you can get by clicking pretty print in the dev tools. Thankfully, most node libraries are also not minified. This is important because if the thing you're trying to patch is JS code that was minified or obfuscated from the TypeScript code, actually going in and doing those modifications sucks. It is what it is. This also reminded me of the most cursed library I've ever seen that's genius. I'm probably going to do a whole video on this. Let me know in the comments if I should. TS blank space has been hurting my brain for a minute. If you have TypeScript source code, but the browser's running JS, and you want to debug something that goes wrong, how do you point the right character to the right place in your source map if the source map is pointing at a different language? TS blank space has a really clever solution. Instead of compiling and writing entirely different code like this, what if we compiled the types out by just turning them into blank spaces that are the same number of characters? It's so stupid, and it's so genius. I think this is awesome. I should probably do a whole video on it. Now you know it exists. Anyways, TypeScript being minified and pointing the right things to the right place is annoying. We're still finding clever solutions, and Bloomberg's even working on it. So yeah, we'll get there. Back to the article. Of course, this also leads us back to debuggability. If I want to debug a JS library, I can simply use the browser's dev tools or a node debugger that I'm already familiar with. I can set breakpoints, inspect variables, and reason about the code as I would for my own. This isn't impossible with WASM, but it requires an entirely different skill set. Very fair point. And on the topic of entirely different skill sets, I can finally do my React Native tangent. I think people don't understand the real value of React Native. It's not that we need to turn everything into the web. It's not that React is the objective correct way of writing. It's that most companies have product and have features in that product that are built by React devs. And some of those features need to end up on the mobile app if they have one of those too. I know that because I worked on a lot of different feature teams at Twitch, and I got to build all those features in React, except for the mobile app, where I had to bug someone on the mobile team to prioritize some time to try and go get whatever feature I want working when they don't know anything about it because they're not on the team that built the feature. And that loop is obnoxious. The back and forth from me as someone who doesn't write native code to someone else who does, trying to get to the point where we can get the features we need in the mobile app. Like, I don't know, a ban button? I'm not saying that native tools aren't good. I'm saying that React Native allows for the parts that don't need that native win to be contributed to by the people who work on everything else at the company. Realistically speaking, even if you're not a JS dev, even if you're like a Go dev, it'll be easier for you to contribute to a React Native code base than to a traditional code base that is in Swift, simply because if you want to add it to the Android app, you need to go switch over to the Kotlin or Android Java project, whatever you're running for the Jetpack world nowadays. With React Native, you only have to learn the one thing. And now you can contribute to the web as well. And since JS, and in this case, React, are effectively necessary for building the dynamic web app, avoiding them on mobile for the sake of it is preventing others from being able to contribute. I would go as far as to say the main reason the Twitch app sucks so hard is because the people at Twitch who use Twitch the most, who care the most about Twitch, aren't on the mobile teams, and they don't get to contribute to the mobile apps as a result. I know that because that's what happened to me. I tried my hardest. I rewrote the app from scratch to show how good a React Native version could be. And I am so sad I can't use it anymore because when I upgraded phones, I lost it because I don't work at Twitch anymore. But man, it's frustrating. Not because React Native is better than native, but because the quality of the tool isn't what matters. It's the quality of the contribution. And if I can't meaningfully contribute because the wall I have to climb to get into that point is so high, you're just never going to build the right thing. And it takes so much more time to figure that out. If I have to learn what does and doesn't work for a feature on web, and I spend 6 months building it, and then we need it on the mobile app, it's no longer a rewrite because I'm not the one doing it. Someone else is. And now that person has to go learn all the same lessons, but that person is less invested because their job isn't this feature. Their job is the app, and their priorities aren't aligned with my team's priorities. And the result is the app slowly gets worse and worse as people who care more about building apps than about building Twitch apps are piling on these band-aids over and over again. It becomes a mess. And as scared as they might be of React Native, it comes with a massive benefit that the people who work on these features and care about this product can now contribute when they couldn't have before. And I really hope people take that part seriously when they're thinking about this React Native versus native debate, the same way we are here with JS versus WASM. JS lowers the floor for contributions, which doesn't mean the quality of things goes down. It means the number of people who contribute goes up. And if those people care enough, it'll go great. And if you're a mobile dev that is working in native technologies and you're scared that React Native being added is going to lower the quality of your app, you are incredibly useful. Push hard to make sure the quality of the app doesn't go down. Help dumb JS devs like me learn what a good mobile app actually is and hold us to a high bar. Don't block us from contributing. Block our contributions until they're good enough. Be the shepherd of the change you want to see. That's my React Native tangent I've been waiting to go on for a while. The other tangent I've been putting off is about the other languages. I've already done this one in a bunch of videos, but I think we over-indexed on Rust and under-indexed on Go. A significant portion of why JS tools are slow is because reading a shitload of files is slow, and you can't do it in parallel without using a bunch of workers in JS. Any language that has good concurrency primitives is going to be slightly better, specifically around parallel stuff, than Node is, because Node isn't properly parallel. It can have a task running in the background and do other things while it waits, but you can't run 3 tasks at once without all the chaos that is workers. In Go and Rust, that's not as much a problem. That said, a lot of the Rust code that I've seen isn't written to work well parallel. And as soon as you try to make Rust work in a parallel environment, it becomes 10 times more work. If instead of our goal being make it so the code runs faster, the goal was make it so the code can utilize our hardware better, Rust might not be the right choice, and Go might be instead. So personally, I think we should have explored Go a little bit more for the JS dev tool world, and that we went a little hard on Rust a little early. That's all I wanted to say there. Let's finish this up because this article's been awesome. I think it's great that there's a new generation of tools for the JS ecosystem. I'm excited to see where projects like OXC and Void Zero all end up. The existing incumbents are indeed exceedingly slow and will probably benefit from the competition. I get especially peeved by the typical ESLint plus prettier plus TSC plus rollup, lint plus build cycle. This author has the best bias callouts, reservations, and realistic things like this where they're admitting this isn't acceptable in its current state. Things are too slow. I feel the pain. But just switching languages doesn't solve the problem. That said, I don't think that JS is inherently slow or that we've exhausted all the possibilities for improving it. Sometimes I look at truly performance-focused JavaScript, such as the recent improvements to the Chrome dev tools using mind-blowing techniques like using the uint8 array as a bit vector. Sometimes the authors of these things are so far ahead of me with the things they check, it gives me imposter syndrome. Interesting. This is to speed up parsing of a snapshot to see if it contains certain things that match a regex by caching the substrings in this bit vector so they can find stuff much faster. On a heap snapshot from Google Docs, this change speeds up the heap snapshot.initialize function from about 3.2 seconds to 2.9 seconds. Clever. Very smart stuff. But yeah, there's ways to make JS faster. To be fair, that's a small percentage win compared to the stuff that we're talking about here, but it's still meaningful, and we have not explored anywhere near enough of these things. As the author says, we've barely scratched the surface. If you really want an inferiority complex, see other commits from Seth Brenneth. They're wild. Yeah, Seth seems to be this JS god on the Chrome team making dev tools better. I roast dev tools in Chrome for their UX all the time, but I've never thought about all the hacks for performance in there. Speed up computation of dominators for heap snapshots. The comments are actually really readable here. First, check for more bits in the current byte. Next, iterate by bytes to skip over ranges of zeros. Finally, iterate the non-zero byte to find the highest bit. I love the bitwise math for parsing heaps. Fucking God mode. Insane. I'm feeling the imposter syndrome here. Thank you for that call out. I also think that as a community, we have not really grappled with what the world would look like if we relegate JS tooling to an elite priesthood of Rust and Zig devs. This is also a fair point. If the only people who can improve our tools aren't JS devs, they're Rust and Zig devs that happen to care enough about JS to bestow upon us these features and tools, how do we innovate? What if I'm a random JS app dev that has an idea for something that I want a plugin for, but I have to write that plugin in Rust? It sets the bar too high. And I think we've had an incredible couple decades of JS tooling innovation, and a significant amount of that has come from the fact that it's not that hard to build a new JS tool. That has given us the meme of there's a new framework every week, but it's also given us a ton of innovation that I miss dearly when I go to other languages. I just spent a bunch of time rewriting the same project in Rails and in Elixir Phoenix. I love one of those solutions. Not the other, but I do love Elixir and Phoenix. But I still find myself missing a lot of the innovations that we've had in the last 5 years in JS because it takes a long time for those to make it to these other tools. And JS is the world where these innovations happen and then they spread to these other locations. If JS is built on other languages, the likelihood that these innovations get built and tested out in the first place goes down significantly. And that's a thing that we need to consider. I can imagine the average JS dev feeling completely hopeless every time there's a bug in one of their tools. Rather than empowering the next generation of web devs to achieve more, we might be training them for a career of learned helplessness. Imagine what it would feel like for the average junior dev to face a seg fault rather than a familiar JS error. Imagine that seg fault happens when they run pnpm run build, but it wasn't there when they ran pnpm run dev. Horrifying. At this point, I'm a senior in my career, so of course I have little excuses to cling to my JS security blanket. It's part of my job to dig down a few layers deep and understand how every part of the stack works. However, I can't help but feel like we're embarking down an unknown path with unintended consequences, when there is another path that is less fraught and could get us nearly the same results. The current freight train shows no signs of slowing down, though, so I guess we'll find out when we get there. I mostly agree. This was a phenomenal article, and I'm already seeing these other titles and really wanting to read them. This one's over 10 years ago, and I still want to read it. JS Devs and the Paradox of Choice, SPA's Theory versus Practice. Oh, there's so much good stuff here. This blog is officially on my read list. Should be on yours as well. Huge shout out to Nolan for all the work on this post. Go check out Read the Tea Leaves at nolanlawson.com. Link in the description as always. How do you guys feel? Should we be rushing to rewrite everything in Rust, or should we take a step back and think if we can do this in JS instead? Let me know. And until next time, peace nerds.